Hi, in this video, we are going to learn about what is turbulent flow and the Reynolds experiment, which has been conducted by O. Reynolds in 1883 to determine the flow, whether it is laminar or turbulent. So, let us proceed. The first point is the difference of laminar and turbulent flow. The second point is Reynolds experiment, and third point is derivation of Reynolds equation. So let us start with the first point. Before starting the first point, we should know that what is a laminar flow. So as we know, laminar flow is the kind of flow in which the fluid particles move along the straight parallel path in layer or lamina, such that parts of individual fluid particles do not cross neighboring particles. So here you can clearly see that in the definition is clearly understandable by reading itself. If each and every fluid is moving in this line, as you can see, and while moving this fluid particles do not cross from one layer to another layer. So that kind of flow is called laminar flow, and it happens when velocity is low, viscosity is high, and diameter of pipe is same or the small. So velocity is low and viscosity is high, then only the flow will be laminar, with provided with the diameter of the pipe or the cross section of pipe is similar all over the section, or it is small as compared to another. So in this you can see the flow of laminar from left to right. You can see here the each particle is moving in the straight parallel path, and it's not crossing line from one to another layer. Turbulent flow. Now let us see what is turbulent flow. It is defined as the flow in which the fluid particles moves in a random manner, resulting in general mixing of fluid particles. So normally it happens when velocity is increased, viscosity is decreased, and diameter of the pipe is increased. When the diameter of the pipe increased, there will be more space for the fluid particles to move around. So there will be chance of fluid particle crossing the path of another fluid particles. So that is meaning of this diameter of pipe is increased. Similarly, viscosity is decreased. Since the viscosity is decreased, the flow will not move in the lamina or the layer. And velocity increase means there will be more acceleration, and the fluid particles will move from one layer to another layer, and it will be random mixing. That's why it's called a turbulent flow. In this video you can see these fluid particles moving randomly in the particular pipe of cross section of pipe. So here you can see the each fluid particle don't have the particular direction to flow, and they are moving randomly in a zigzag way. Now let us compare laminar flow and turbulent flow in the tabular form. Here you can see there is one table. In the left column we have listed the properties of laminar flow, and in the right column we have listed the properties of turbulent flow. So as we have already seen that in laminar flow, fluid particles moves along the straight parallel path in a layer or a lamina. And in a turbulent flow, the fluid particles moves in a random manner. They don't have any particular path. And the velocity of the fluid flowing in the laminar flow is low, with viscosities at higher side, and diameter of the pipe is small. Similarly, opposite to these properties, turbulent flow has velocity is increased, viscosity is decreased, and diameter of pipe is also increased. If we narrate this flow in terms of the arrow diagram, we can see here this each and every fluid layer moving in a straight path, and that straight path is parallel to another fluid layer. So the flow of fluid follows this pattern when the fluid is flowing from one section to another. But opposite to that, in the turbulent flow, the fluid flows in a random direction. It does not have any particular path. See here, you can see the fluid has making this curve and it is entering in another liquid layer. Similarly, this path also, and here you can see the fluid entering here and there, and this fluid particle has also rotating about their own axis. But whereas in this, the fluid particle do not rotate about their own axis. Okay, so this is the difference, major difference between laminar and a turbulent flow. So in general, it is very difficult to judge that which flow has the laminar flow properties and which flow has got the turbulent flow properties. So in order to get that easily, the Mr. Reynolds has done one experiment in which he has suggested one number which has not got any dimension. That number is called Reynolds number, and that Reynolds number is given by the equation, that is RE is nothing but the Reynolds number, is equal rho Vd by mu. So when we put all this value of these quantities related to fluid flow parameters, then if you get the value of Reynolds number more than 4000, that flow is said to be turbulent flow, and this is case is for the circular pipe. Similarly, if the value of Reynolds number is less than the 2000, then the flow is said to be laminar. And if the RE value, that is Reynolds number values, lies between 2000 to 4000, the flow changes from laminar to turbulent, or else we can also call it as a transition phase of the flow, while the flow is transmitting from laminar to turbulent flow. In the experiment, he has this apparatus, he has developed one apparatus. Here you can see in the sketch. Here this apparatus consists of a tank containing water at a constant head. You can see it is indicated by number 1. The second one is a small tank containing some day kind of a liquid which has got some viscosity, and which has got a specific weight as that of this liquid, or you can say as a water, since this liquid is nothing but the water. And third one is glass tube having this regulating valve to control the speed, control the velocity of the fluid flow. So the water from the tank is allowed to flow through the glass tube by this regulating valve, and the velocity of the flow is varied by this regulating valve. A liquid day having the same specific weight as that of water was introduced in the glass tube, as you can see in this figure. In this red line indicate that a day is coming from this tube, coming from this tank, entering in the glass tube. On the This was the initial setup of Reynolds experiment. When Reynolds find the experiment, he has also found the 3 observations of him. That first one was, when the velocity of flow is low, the day filament in the glass was in the form of straight line, and the straight line of the day filament was parallel to the glass tube, which has case of laminar flow. Here you can see that when we are turning this regulating valve on, while this water is moving in this glass tube, and we are opening this valve, such that velocity in the fluid in the glass tube is low. In this situation, when we introduce this day in the glass tube, it has got the straight flow, and this flow is parallel to this glass tube, and this then Reynolds has made his second observation as that with the increase of velocity of flow, the day filament was no longer the straight line, but it's become a wavy one. This shows that the flow is no longer laminar. His third observation is that with the further increase of velocity, the wavy day filaments broke up and finally diffused in the water. When he is further increasing the velocity of the water, that the flow velocity of flow is increased, and in that condition if he is introduced the day filament in the glass tube, it will get diffused and it will flow randomly, disorderly, and flow will be irregular. Here you can see when wall is turned on and velocity of flow is the higher side, the flow of difilament will be in the diffuse form. So here you can see the flow is diffused and it is moving along with the water in the diffused form. So this was his third observation with his experiment. After he has conducted his experiment, he has made some observation, and from that observation he had given the two conclusions. That is, first one is, in case of the laminar flow, the loss of pressure head was found to be proportional to the velocity. Hence, we can see here the loss of pressure head, that is nothing but when the fluid is moving from one point to another point or from one end to another end, it has got some loss of pressure head, that is nothing but the pressure that has been reduced while fluid is flowing from one end to another end. This is because of the viscosity what fluid has got and the shear stress introduced in the fluid due to viscosity. So that loss of pressure head is due to the velocity of this fluid. And second conclusion was this: in case of a turbulent flow, the loss of pressure head is approximately proportional to the square of velocity. So that loss of head is approximately proportional to the square of velocity. Hence, the HF is nothing but the loss of pressure head is equal V raised to n, where n varies from 1.75 to 2. This is a conclusion of Reynolds from his experiment. So with this, we will proceed further and derive the equation that is given by the Reynolds. So the derivation of Reynolds equation. So Reynolds equation is nothing but the ratio of inertia force of flowing fluid and the viscous force of the fluid. So from this definition, it will be clear that Reynolds equation is nothing but ratio of inertia force to the viscous force. So inertia force in the fluid will be given by mass into the acceleration of flowing fluid. So mass of the fluid is given by rho into the volume. So rho is the density and into the volume of the fluid, and acceleration is nothing but the velocity divided by time. And when we rearrange this equation, so it will become rho into volume divided by time. This time will come to this side, we'll just rearrange it, and this equation will become as this one. Hence the volume by T is nothing but the discharge. Therefore we know that discharge is equal to the area into velocity from the continuity equation. Now this volume into time is going to be replaced by the Q, and Q is nothing but the A into V. So this equation finally will become as rho into A into V square here. And let us consider this as the equation number 1. Now the second terms in the Reynolds equation is about a viscous force, and viscous force can be represented by the shear stress into the area, and shear stress is nothing but the difference in the velocity gradient, which you can see here. The shear stress is given by tau, and it can be written as mu into du by dy. That is nothing but the velocity gradient into the area here. When we solve this du by dy is nothing but the velocity gradient, and it can be represented by this one. The force what you have seen, the shear stress, that is force into the area which comes here, and this du by dy will be equal to the velocity into the length, means velocity gradient. Okay, so this equation will give name as the number 2. And by definition of the Reynolds number, that is nothing but the Reynolds number is a ratio of inertia force to viscous force. Here you can see we have written here, and when you substitute the values of this inertia force and viscous force from the equation number 1 and 2, we are going to get is this one, rho into A into V square by mu into V into L into A. Upon solving this, we can see here the A, this V and this A is going to cancel, this V and this V also going to cancel, and remaining is only V, and this L is going to multiply to this side. So it will become as rho into V into L by mu. So if we divide this equation by rho, then we are going to get is this one, V by V into L by mu by rho, and mu by rho is not nothing but the kinematic viscosity. So these terms will get replaced by the nu, this one. So final it will become as a V into L by nu. So this V is the velocity, and this nu is a nothing but kinematic viscosity. So conclusion is that in case of the pipe flow, the laminar L is taken as a D. If the flow is flowing from the pipe, the L will be get replaced by the D, and the Reynolds number of the pipe flow will be given by Re is equal V into D by nu. Nu is a kinematic viscosity, and this V is a velocity of fluid flow, or it can be given by rho Vd by mu. Here this is the density, this is the velocity, this is the diameter of pipe, and this is viscosity. Okay, and that was about the Reynolds equation. So guys, I hope you like the videos, you learned something from this video. If you learned something from this video, please subscribe this and share on your contacts.